In this video, I explain how to solve equilibrium in a partial equilibrium setting, both graphically and using equations. Both are fundamental skills for many economics classes. I begin by reviewing the demand function and the inverse demand function. The demand function, or demand curve, gives the amount collectively demanded by consumers in the market at any particular price. The outcome variable in this function is quantity, and the input variable it depends on is price. The inverse demand function, or inverse demand curve, is the reverse. Price is the outcome variable, and the input variable it depends on is quantity, hence why it is called the inverse demand function. One might ask how to interpret the inverse demand function. The inverse demand function can be thought of as giving the highest price for which the specified quantity is purchased in its entirety. It might tell us, for example, that if there are 8 units for sale, then the highest price such that all 8 units are bought is $10. Note, one can manipulate the demand function to get the inverse demand function, and vice versa, because they essentially provide the same information, albeit in slightly different ways. For example, one could get the inverse demand function by rearranging the demand function to solve for price as the outcome variable. I will follow convention and plot the inverse demand function. Hence, the output variable, which is price, is on the vertical axis. The input variable, which is quantity, is on the horizontal axis. Suppose there are just enough willing consumers to buy 8 units of the good when the price is $10. Then this is one point on the inverse demand curve, which we can draw. Suppose there are just enough willing consumers to buy 6 units of the good when the price is $12. Then that is another point on the inverse demand curve. If we connect all such points, then we get the inverse demand curve, the entirety of it. We can also plot the inverse supply function, which, as you might guess, is the inverse of the supply function. The supply function gives the amount that producers are collectively willing to supply at any given price, implying that quantity is the outcome variable in the supply function. Its inverse, the inverse supply function, has price as the outcome variable. It tells us the price at which producers are collectively willing to supply a specific quantity of output. Because the inverse supply function has the same output variable as the inverse demand function and the same input variable as well, we can plot it on the same graph. Suppose that 4 units are supplied when the price is equal to $6. That is one point on the inverse supply curve. If we combine all such points, we get the inverse supply curve. The point where inverse demand and inverse supply intersect is the equilibrium. We call it an equilibrium because it is stable. Neither consumers nor producers would want to change their decisions. We can solve for equilibrium more precisely if we have equations for demand and supply. We can set the demand function equal to the supply function, then solve for the value of the input variable, price, which indeed makes them equal. Let's go over an example. Suppose that the quantity demanded equals 18 minus the price, and the quantity supplied equals 2/3 times the price. Let's set them equal to each other and then solve for price. So now we have an equation of one variable, we can simply solve for price. Let's start by adding price to both sides of this equation. That yields 18 is equal to 5/3 times the price. If we multiply both sides by 3/5, then we get that the price is equal to 54 divided by 5. And then we could plug that price into either the demand function or the supply function to get the quantity in equilibrium. If one does that, one gets that the quantity is equal to 36 divided by 5. This short video shows how to solve for equilibrium in partial equilibrium analyses. In partial equilibrium analyses, we assume that we can consider one market in isolation and that there aren't any important interdependencies between two different markets, such as the markets for corn and for wheat. This assumption isn't exactly true, but it is often good enough to help us solve problems approximately and gain intuition. Partial equilibrium analyses are used frequently in subsequent videos.